Alrighty, this is the second part of the topic. This is looking at, we're going to look at the measures of center and the measures of variability. So the measures of center, I have a data set. They're in order, so I don't have to worry about that. But the measures of center are the mean, median, and the mode. Okay, so we're going to go ahead and find those again. So the mode is the most, so that would be the 5s, because there's 2 of them, the 8, because there's 2 of them, and the 10, because there's 2 of them. The median is the middle, so when we come through, fancy finger trick, and match them up, we see the median is the 7. The mean, we're going to add those all up. So when I add this up, I come up with 63. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. So 63 divided by 9 is going to give us 7. So our mean is 7, which is also the median in this case. Okay, these are the measures of center. We can also find our range, which is our largest number, which is the 10, minus the smallest, which is a 4, and that gives us 6 is our range. Our min is 4. Our max is 10. We can find our Q1 and our Q3. Remember, we already have our Q2, which is our median. So our median is also known as the Q2. All right, so to find our Q1 this time, I'm not going to use the median because it's already been used. We're going to find the middle of the lower half, and it's actually going to be between those two 5s. So to find that, we're going to take the 5 plus the 5, which is 10, and then we're going to divide by 2 because we're finding the average of them, and it's still just 5. So the Q1 is 5. The Q3, so we take those 2, so it's going to be between the 8 and the 10. So we're going to take 8 plus 10, which is 18. And we're going to divide by 2, and we get our Q3 is 9. So we could form a box plot now. But what I want to look at now is, well, we're going to find the IQR. We talked about it, but we're going to look at it again. This is a measure of variability. So the IQR, you're going to take your Q3. We're going to take our Q3 minus our Q1, and that gives us 9 minus 5, which is 4. So our IQR is 4. This is a measure of variability. The other measure of variability is your MAD, mean absolute deviation. Okay, so we're going to work on that now because that takes a little bit more time. All right, so looking at our numbers again, what you're going to do is you need to find the average, or the mean. So the mean or the average is 7. Okay, we added those all up. We had that 63 divided by 9, that gave us 7. So our mean is 7. What you do is you take the absolute value of your mean minus each number in our list. So we're going to start with 4. 7 minus 4 is 3. Absolute value of that is still 3. All right, we take the absolute value of our mean minus the next number. Well, there are 2 of them, but you are taking it of both. I'm just going to mark that I have 2 of these so that I don't forget when I go back to work with this. 7 minus 5 is 2. Absolute value of 2 is still 2. We take the absolute value of the mean minus the next number, which is a 6. 7 minus 6 is 1. Absolute value of 1 is 1. Alrighty. absolute value of our mean minus the next number, which is a 7, which is 0. The absolute value of 0 is 0. We take the absolute value of our mean minus the next number. There are 2 of these, so I'm going to make a note of that. And the next number is 8. Now, we have not officially done integer operations, but we've talked about this in that if you have $7 and you just purchased something for $8, well, you owe $1. You are in debt $1. So the absolute value, though, of that in debt, or -1, is 1. All right, and then we're going to take the absolute value of our mean minus the next number. Again, there are 2 of those, so I'm going to make a note of that, which is 10. 7 minus 10 is a -3, and then the absolute value of that is the +3. Okay, this is absolute deviation. Now, to find the mean absolute deviation, okay, so now we're going to find the MAD. What we're going to do is we're going to take all of these numbers and add them up. So we have a 3, we have 2 2s, we have a 1, we have a 0, we have 2 1s, and we have 2 3s. All right, when we add that up, we get there are 16, or the sum is 16. Now, there were 9 numbers, so we also still have 9 absolute deviations, or we should. And 16 divided by 9 is, I'm going to work this out because some of the students are not liking this. We take 16 divided by 9. 9 goes into 16 one time. When we subtract, that leaves us 7. Oh, I'm sorry. Okay. But we can't have a remainder, so we're going to add a decimal and a 0. Bring that down. 9 goes into 70 7 times. Don't forget to bring the decimal up. 9 times 7 is 63. And again, it leaves 7. So when we add another 0, we can see it's just going to continue to go on and on and on. What it means is your 7 is being repeated. It is a repeating decimal. So your MAD is 1.7 repeating. And that is another measure of variability. But it definitely takes more time. In the notebook, we had this worksheet. So we have the definition of absolute deviation, and we have an example in the book. And then we have the definition of mean absolute deviation and an example, or continuing on that example in the book. And we also talk about the interquartile range, and we have an example in the book. This is all measures of variability. When you use centers, measures of centers and measures of variability, we talked about that if there was no outlier, an outlier is somebody that lives outside of the box. If there is no outlier, you would use the mean as your measure of center. And then we talked about, and I know this is not a great way to remember, but if you are mean, you are MAD. So if you use the mean because you have no outlier, then your measure of variability, the best one, would be your MAD. So if you are mean, you are MAD, and hopefully that'll help students remember which ones to use. So the measures of center, you use mean when there is no outlier. You use the median when there is an outlier, when somebody is way outside of the box. If you choose to use your mean as your measure of center, then you would use your MAD as the measure of variability. Whereas if you use the median as your measure of center, you're going to use the interquartile range as your measure of variability. Alrighty. Some students will get a chance to see this information, but not everybody, and it is not included on the test. We talked about how the shape of the data is. If you look at something like this, you can see it's pretty much symmetrical. There's pretty much the same on both sides. This is when it is called symmetrical, and the data is pretty much on both sides of the point or the center. If it is left skewed, it has a left tail, meaning that it has more data on the left side of the peak. And an example of that would be something like this one, where there is more of a tail on the left side because they just kind of keep going. The other choice is right skewed, and this would have a tail on the right side because there's more data on the right side of the peak. An example of that would be this colorful histogram because the peak or the tail on the right side keeps going. As I mentioned, this is not used on the test, but it is something I wanted to have a chance to go over in some of the classes. One other thing, when you're looking at this data, I can see that it is right skewed because it has a tail on the right side, but I can also see that I have an outlier. This is a data point that is outside of the box. If we have a data point that is outside of the box and we have an outlier, we know that if we have an outlier, we're going to use the median as our measures of center, and we're going to use the IQR as our measure of variability. This is just for those students that are really interested in this and might choose to take some statistic courses later on. And that is all for topic 8.